Hello everyone. This week we will explore the sheet metal toolbox in Solidworks. Solidworks has a vast set of tools designed for the purpose of modeling sheet metals. We can either use a solid design and convert it into a sheet metal design, or we can start from the scratch like we did for the surface modeling tools, or maybe if you want to design something similar to a solid design. There are many products around us that are made by the sheet metal manufacturing process system. For example, the casing of your computer, the power cable casing for protective maintenance, say knives, etc. These are only some of the examples. In manufacturing world, it is one of the most common used technique. So let's say you're using a sheet metal toolbox and created a 3D design like this. Once you're done, there is an option called unfolding or unrolling. If you use that, it will create this flattened design. And this is the design that goes onto the manufacturing floor. Basically, the machine shop guys use this design to cut away the exact portion of metal from the sheets so that you can later on use the bending tools to create this 3D object. Before starting with the sheet metal tools, one might be interested in knowing a few of the important factors. One is the properties of the material they're using, especially the hardness of the material. Because when you're bending, if you bend the material too much, it might break. So knowing the material properties is important beforehand. Then the thickness of the material, how much force we might need to apply on it. While you're performing the bending, you might want to know the bending radius for that material, of course. So, of course, this bending radius depends on the property of the material and the thickness of the material. There is already a predetermined chart that can be found in this link, which you can use to get the values for the minimum bend you can apply on that material. An example is this for for the cold rolled steel, when the thickness is 22 gauges or maybe 0.76 millimeter, you can apply a minimum bend of this. Okay, and the bend radius will be around 2.29 millimeter. This is the suggested value for the bend radius. Again, let's say if you don't even know the bending radius, you can also use the thing called K factor. K factor is the ratio of metal sheet's thickness and the neutral axis of that material. It's a unique value for each material and for each bend radius. If you know the K factor, it's easy to calculate the bend radius from it. And knowing K factor also gives you an idea how much elongation or bend deduction will be applied or occur on the material. You can get the predetermined values from this link here. This table shows only one example of how it is and which, depending on which method you're applying and what is the thickness and what material you're using, what factors you need to apply or decide. Okay, now that you know these things, let's first activate the sheet metal tool on SolidWorks and then create our first design. Okay, so we started SolidWorks. Let's start a new part design. Click OK. Like before, we need to first activate the tab of sheet metal and then create a new design. So on the top here, right click on it, go to the tabs, and here you will find the sheet metal option. Clicking on it, it will activate the sheet metal tab here, as you can see. Okay, so now let's create our first design. We'll start with the plane. Let's see the front plane. We right click on it and click the sketch button. Okay, for this example, let's make it an easy example. Okay, we select the center rectangle and we start from the center point. Let's say we have this as 150 millimeters by 50 millimeters, something like this, right? Let's go to the sheet metal and let's use the base flange tab. This is similar to the base extrude option in the solid. So click on it. It is already selected the tool itself. From here you can select, as you see on the left property manager, you can use these values to define the parameters. For this one, let's keep the auto relief to rectangle, uh, the bend allowance to K factor. You can also change it from the bend table. Okay, we can just go to the bend table that was shown in the link on our previous presentation. Throughout this tutorial this week, we will be using the K factor. So let's keep it at 0.5. We also have the different sheet metal parameters, and so you can also use the material sheet parameters from here by selecting this. Okay, as we haven't applied any material on this tool, it will not show up at the moment. Then we also have the sheet metal gauges. Of course, we need to apply a material first, which we can do it from the design library, as you can see on the right side. Let's keep it like this for the moment and click OK. And this is the sheet metal design we have with a certain thickness. Okay, so let's do a additional design here. Let's select this face here and create a new sketch. So go to the sketch, create a sketch. Okay, so we have this new sketch here. Let's create another rectangle. This time we'll be using this point to point or the corner rectangle. So we will start from this point here and finish somewhere around here, and the dimension will be around 150, something like this, right? So as you can see, it is this. Go to the sheet metal, go to the base flange tab, and once we're done, click OK. So now you have created your first sheet metal design. And when we go into the production, we'll basically be sending them this flattened design, because we don't have anything interesting. Once otherwise the 3D object will look something like this. Okay, so that's all for today. We will go into the details of each tool from the next video.